This is an additional component to section 5.4 on more trigonometric graphs. I'm going to go back and revisit the tangent graph. So here's the thing. I haven't taught graphing of tangent and cotangent in a lot of years, and I made the mistake of not going back and reviewing it before I went back to teach it. So I messed it up royally. We're going to fix it here. So going back to one period of the tangent graph, I could pick any one of the periods we talked about in class, but I'm going to pick this specific one. I'm going to pick the part of the graph that was between pi over 2 and negative pi over 2. So this is where one of our periods was at. And then the graph of tangent is at 0 when the radians are 0. And then at pi over 4, the tangent is 1. And at negative pi over 4, the tangent is negative 1. And so this is what the graph looked like. And we're going to focus on just this. So now the question is, well, what happens if I change the period? So the period is either going to shorten how far apart those asymptotes are, or it's going to lengthen how far apart they are. And this is where I should have gone back and reviewed this, because there's a specific process for determining where the new asymptotes will be. And it's very easy. So let's look at a transformation on the graph of tangent. Let's look at the tangent of 2x. All right, so the period is going to change because k is 2. So the period is going to be pi over 2. So instead of the period being 1 pi, the period is going to be pi over 2. That shortens the length of the distance between the asymptotes. So how am I going to determine where to put those asymptotes? Well, remember here that the asymptotes were at pi over 2 and negative pi over 2. That's because the tangent of 90 is not defined, and neither is the tangent of negative 90. So any value of x that'll make this quantity equal to either pi over 2 or negative pi over 2 will result in an asymptote. So what we're going to do is we're going to set that quantity equal to negative pi over 2 and solve for x. And I'm going to get negative pi over 4. And then I'm going to set that quantity equal to positive pi over 2. What I'm doing is I'm setting that quantity equal to each end of the period. Alright, so then I'm going to get x is positive pi over 4. So now, when I go graph this, instead of the period going from negative pi over 2 to pi over 2, now it's going to go to it's going to start at negative pi over 4 and end at pi over 4. So here are my new asymptotes. And then these 2 points are where I'm going to hit 1 and negative 1. What are those 2 points? Well, this one's going to be pi over 8, and this one over here is going to be negative pi over 8. So there are my 5 tick marks. Let's do this again. Let's look at y is equal to the tangent to x minus pi over 4. This one has a period change and it has a phase shift. Now the nice thing is that I don't even have to, I know that the graph gets shifted pi over 4 to the right. That's not the problem. In order to figure out where I'm going to start and end my period, it's different than what I did for sine and cosine. To figure out where I'm going to start and end my period, I'm instead going to take this quantity and I'm going to set it equal to negative pi over 2, and I'm going to set it equal to pi over 2. So with sine and cosine, we found the beginning and end of our period by doing the phase shift, comma, phase shift plus period. For this one, we're going to find the beginning and end of our period by setting what we're taking the tangent of equal to each of the asymptotes. This is going to find my new asymptote. Alright, so I'm going to solve the first one. First I'm going to divide by 2. So I'm going to get x minus pi over 4 is equal to negative pi over 4. And then I'm going to add pi over 4 and I'll find out x is 0. So that's where one of my asymptotes is going to be. The next one, I'm going to divide by 2. And then I'm going to add pi over 4. And pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. So this time, my tangent graph is going to start at 0, and that's where my first asymptote is going to be. And my ending asymptote is going to be a pi over 2. So the one that's smack dab in between is pi over 4. That's where I'm going to hit the x-axis. And then this is going to be pi over 8, and that's where negative 1 is going to be. And then this is going to be 3 pi, oops, I should make that a pi, 3 pi over 8, and that's where positive 1 is going to be. And there's my graph. So I've changed the period. You know, if you go back up here, the period is going to be pi over k. So we know what the period is. Hey, look, the period is pi over 2. And we shifted the asymptotes to the right, to the right, pi over 4. That's what happened here. So I'm going to do this one more time. But again, the tangent graph, in order to graph one period of the tangent graph, instead of doing the phase shift, comma, the phase shift plus the period, my asymptotes are instead going to be at the values of x, where what you're taking the tangent of is equal to negative pi over 2 and positive pi over 2. Now we could do this with other points. I believe when I started teaching this several years ago, instead of using negative pi over 2 and positive pi over 2, I have a sneaking suspicion I used to use pi over 2 and 3 pi over 2, which are the next set of asymptotes. I think this is a better way to do the problem. Alright, let's do this one more time. And all I'm doing is I'm just going back to either problems that are in the book or problems that we did in class. So this is one that was smack dab out of our notes. I want to graph one period of tangent 1/3 x minus pi over 2. So in order to figure out where my asymptotes are for this particular graph, and then the graph of it will be between it, we're going to take what I'm taking the tangent of, which is 1/3 x minus pi over 2, and we're going to set it equal to negative pi over 2, and then we're going to set it equal to positive pi over 2. So first I have to multiply by 3, and then I have to add pi over 2. So negative 3 pi over 2 plus pi over 2 is going to be negative 2 pi over 2, which is negative pi. And then in the second one, I'm going to multiply by 3. And then I'm going to add pi over 2. And 3 pi over 2 plus 1 pi over 2 is 4 pi over 2, which is 2 pi. Now, let's go back up here for a second. Remember, the period is pi over k, and the period is 3 pi. So when I graph this, the distance between my asymptotes better be 3 pi. So we're going to make one of them is going to be at negative pi, and then the other one is going to be at 2 pi. Well, the distance between those is 3 pi, because you're going 2 pi this way and 1 pi that way. That's 3 pi. So my period must be right. Smack dab between 2 pi and negative pi is going to be pi over 2. So that's where I'm going to hit the x-axis. And now I need to find my other two tick marks where I'm going to hit 1 and -1. So the first one is actually going to be at -pi/4, so I want to make sure I'm in the negative region, and that's where I'm going to be at -1. And then this one here is going to be at 5pi/4. And there's my graph. Now let's talk about what happens if instead of tangent I'm dealing with cotangent. So here was one period of the cotangent graph. Its asymptotes were instead at 0 and pi. And then the graph between it went down from left to right. So in order to do a transformation on this graph, what I'm going to do is I'm going to figure out where my new asymptotes will be by setting what I take the cotangent of equal to 0 and to 1 pi. Like in the previous problem, I set it equal to -pi/2 and pi/2 because that's where the asymptotes of tangent are. For cotangent, the asymptotes are at 0 and pi. So, here's an example. Y is equal to 2 cotangent 3x minus pi/2. We'll deal with that in a minute. So I'm going to set 3x minus pi/2 equal to 0. And I'm going to set 3x minus pi/2 equal to pi. And then we'll find where our new asymptotes will be with the period and phase shift. So I'm going to add pi/2. And then I'm going to divide by 3, and I'm going to get pi/6. For the second one, when I add pi plus pi/2, I'm going to get 3 pi/2. So when I divide by 3, I get 3 pi/6, which reduces to pi/2. So this is where I'm going to start, and this is where I'm going to finish. All right, so now I'm ready to go draw my graph. Okay, so I'm going to start at pi/6. I'm going to end at pi/2. So there's the start, the end. I got to figure out what's smack dab in between. Remember, it's the average. So 1/6 plus 1/2 divided by 2, pi/3. All right, that's that one. And then these, instead of being at 1 and -1, because of that 2, they're going to be at 2 and -2. And halfway between 1/6 and 1/3 is going to be 1/4, or pi/4. And then halfway between 1/3 and 1/2 is going to be 5 pi/12. So this is at 2, this one's at -2, and then there's my graph. Let's do this one more time. Y is equal to 3 cotangent pi x minus pi. This was one of the ones we did in the notes that I did incorrectly. We're going to start by setting what we're taking the cotangent of equal to the asymptote. So one of them's going to equal 0. The other one's going to equal pi. So the first one, pi x is equal to pi, so x is equal to 1. The second one, pi x is equal to 2 pi, so x is equal to 1 pi. But one of the numbers is in terms of pi and the other one's not. So we're going to just make them decimals. So we'll make that 3.14. This tells me that the in-between, the ones that don't hit the x-axis, they're going to be at 3 and -3. So now I'm ready to go draw my graph. And my asymptotes will be at 1 and 3.14. So the one that's smack dab between is going to be at 2.07. That's the x-intercept. This one is halfway between 1 and 2.07, which is going to be at 1.54. And that one's going to be at 3. And then that one's going to be between 2.07 and 3.14, which is going to be at 2.61. And it'll be at -3. And there's my graph. So, in review, when we do sine and cosine graphs, in order to figure out what interval I'm going to graph it on, when I change the period and I phase shift it, it's going to be between the phase shift, that's going to be your starting point, and the phase shift plus the period. That's your interval. If the graph is tangent, your interval is between two sets of asymptotes. So to find those asymptotes, you're going to set what you're taking the tangent of equal to -π/2 and solve for x, and take what you're taking the tangent of and set it equal to +π/2 and solve for x, and that's where your new asymptotes will be. However, for cotangent, my asymptotes of the parent function are different. They're not at -π/2 and π/2. The parent function for cotangent, they're at 0 and 1π. And that's how you're going to determine your intervals that you're going to graph on. For tangent, usually the graph will look like this between the asymptotes, and for cotangent, it will normally look like this. There's an exception to that rule, which is if you multiply the function by a negative, it will flip the graph over because it reflects it over the x-axis. And I hope that helps out with the graphing for tangent and cotangent. Again, you're going to have 5 tick marks, just like we do for sine and cosine. The only difference is instead of having 5 points on the graph, you're only going to have 3.